which would mean we are starting now. So
go.
Hi. Welcome to DTN Working Group at IETF 122. A couple of things, since this is the first day, please, if this is your first IETF meeting or you have not seen this before, please understand that we have various processes and policies that are documented. In particular, they are documented in these particular BCP bullets sort of at the end, and to draw particular attention to the note really well, which is our guides of conduct, our anti-harassment procedures, and the fact that we're here to have technical discussion and we may sometimes disagree, but we can always do that respectfully. Separately, please make sure if you are certainly in the room that you have signed in to Meet Echo, either the full tool or the on-site tool. The on-site tool is graphically depicted here, is available on the agenda. If you come to the microphone, please also join the queue in Meet Echo so that we know you have a question. Also, if you are remote, please make sure that your audio and video is off unless you are presenting to avoid any live mics. Lastly, here are some information for the rest of the week and the meetings. And as I mentioned before, we have a very, very packed agenda, and we will try and get through it as best we can. Let me pause here for a moment and ask if anybody has any additional agenda bashing or comments. Okay. All right, before we go to that comment then, if you want like 30 seconds after, just do we have note takers? Or so if someone can, please join the shared notepad and take notes throughout.
And I'll add to that is, please can you monitor the shared notepad in case people type your name incorrectly, and just to correct some of the spellings and so on, even if you're not directly contributing to the notes, but please do. It's a collaborative environment.
Eric.
Yeah, I just want to take a quick second to say this is the March IETF. This is when we seat a new series of area directors and IAB members. There's no change for INT area at this time. The other AD, the other Eric, is returning for 2 more years. I'm starting the second half of my third term, but I presently don't intend to run again in March. So if you think you want to be an INT AD, or if you want to be an area director of any other area, now might be a good time to start thinking about that. Applications will open in the summertime, but now is also a good time to start greasing the wheels with management and setting expectations if this is a thing you think you want to do. If you have questions about what it means to be an area director, you can find me or any other current or past AD and fire away. So please consider applying.
Have we got Camilla in the queue? Yeah.
We do. Thank you, Eric. And Camilo.
Hi, good morning. I see that Teresa has been added to the agenda at the very end. I believe she will not be able to present today, so I think we can remove it from the agenda.
So.
Hi. Sorry.
Okay.
I will be able to present. I'm sorry. I just joined a little bit late. I had problems connecting.
Okay.
No problem. That's fine. We'll keep it on the agenda because also Benjamin said he would stand in for Britta if needed, but we'll go with Britta and we'll worry about it at the end.
So we have the reference scenarios, the transfer, the QoS, and the key establishment. I think we are all good. Is that correct?
Yes, I believe so.
All right. Thank you. Last thing, just as a reminder, we do have a set of working group documents that we are working on. In particular, we see bundle and bundle encapsulation, some of the network management work, the work on endpoint patterns and secure advertising and neighbor discovery, and some of that sort of doesn't render quite so well in Meet Echo. We also have a large number of internet drafts, so we are going to be presenting today a mix of the status of some of the things that are here and then some new things that would be under consideration as well. All right, and with that, we will begin, and our first presentation is going to be CoAP over BP. Carlos? Get you.
Reset the timer.
And the clicker is not quite so working, so I can advance this slide. It says.
Okay. Great, thank you. Okay, hello everyone. My name is Carlos Gomez, and I'm going to present the last updates of the draft entitled Constrained Application Protocol CoAP over Bundle Protocol. My co-author is Ana Calveras, and we're both from UPC. Next, please. So on the status of the draft, today I'm presenting revision 02 and 03. 02 was actually presented in Dublin, but only in the core working group, which is the one that defines QAP protocol and its ecosystem. And the reason is that we wanted to first get sort of a validation from there on a new QAP option, which is intended to enable message aggregation, which, by the way, is a feature that was suggested here in DTN. So we believe that we have such validation. So today I'm presenting 02 and also 03. So most of it is about message aggregation, but there's also other functionality, as you will see later. Next, please. So this is the updated table of contents. There are several new sections or subsections. Again, many of them relate with the new option and message aggregation, but there's also a new section on proxying, which is rather orthogonal to that. Next, please. The first new subsection is entitled New Terms. So first, we define the term as a single message that would be, say, normal QAP message as defined in the base QAP specification. And specifically in QAP over BP, a single message would be carried as the block type specific data field of the bundle payload block of the encapsulating bundle. And then an aggregate message would be a concatenation of single messages that carry the payload length option. In QAP over BP, an aggregate message is carried as the block type specific data field of the bundle payload block of the encapsulating bundle. Next, please.
Oh, sorry.
Yeah. Thank you. So yeah, section 4.3 defines the new QAP payload length option, which indicates the size of the payload of a QAP message, and the option value is an integer number of bytes, and it allows message aggregation because it allows a receiver of an aggregate message to recover the different individual single messages the aggregated message is composed of, and it may be compatible in some scenarios with application requirements such as additional delay, while allowing to reduce protocol overhead. Then on the lower part of the slide, you can see a formal definition for this option, and it has some properties. So the option is critical, meaning that if the receiver doesn't recognize it, it still may need to send some sort of response. It is safe to forward by a proxy that doesn't understand it. It is part of the cache key when a response needs to be sent from a cache, and it is not repeatable, meaning that it can only be once present in a QAP message. Next, please. Then section 5 is the one that provides details about the bundle that encapsulates a QAP message. Here, first we define a new parameter, which is max aggregation delay, which would be the maximum time since the first single message being aggregated is generated until the corresponding aggregate message is passed to the BP layer for encapsulation. And then we've also added that the lifetime field of the bundle that carries an aggregate message will be set to one of three possible values. If the aggregate message only comprises con messages, then the bundle lifetime would be exchange lifetime plus max aggregation delay. If the aggregate message only comprises non-messages, the value of the lifetime field of the bundle would be non-lifetime plus max aggregation delay. And otherwise, if the aggregate message comprises a combination of con and non-messages, then it would be the maximum of exchange lifetime and non-lifetime, which usually should equal exchange lifetime plus the maximum aggregation delay. By the way, as a reminder, con messages are those QAP messages that request an acknowledgement from the receiver, and non-messages are those that do not request an acknowledgement. Next, please. So section 9 is a new section on proxying. Here we first provide an overview of the concept of a QAP proxy and the potential benefits it may provide. So this is defined in the base QAP specification. And the QAP proxy is actually a QAP endpoint, which, however, usually acts as an intermediary, which is mostly concerned with forwarding requests from clients and relaying back responses from a QAP origin server. And in the process, it may perform tasks such as caching, namespace translation, or protocol translation. So, among others, a proxy, QAP proxy may serve as responses from a cache in order to reduce response time, network bandwidth, and energy consumption, which are benefits that we believe may also be useful in the environments where BP is used. Next, please.
Actually, I do, just to put myself in the queue for a moment. for namespace translation, can you say just a little bit more on that translation and how that might be impacted in a delayed environment in terms of synchronizing namespaces across that environment?
Yeah, the impact might not be something bad in the sense that the proxy may know how to deal with some request that maybe was made assuming some destination sort of namespace, and the proxy itself may know what is sort of the corresponding translated name for that. So there might not be like an actual impact from that point of view.
Thank you.
Thank you. So then we illustrate a couple of scenarios containing a proxy, a co-op proxy between a co-op client or a client in general and a co-op origin server. The one on top includes a co-op to co-op proxy. So co-op is used by both the client and the co-op origin server, whereas the second scenario includes an HTTP to co-op cross proxy. So in this case, the client would be using HTTP. And the concept of an HTTP to co-op cross proxy is actually well defined, and co-op has actually been designed on purpose to support easy mapping with HTTP messages. Next, please. Then in section 11, we have added some more content. This is the section on securing co-op over BP. And we've added that BPSec allows to protect all the fields of a co-op message carried over BP. This is in contrast with the other option that we've mentioned sometimes, which is OSCORE, which provides object security at the co-op layer. OSCORE allows to protect the payload of the co-op message and also some of the co-op header fields, but not all of them. However, in scenarios with co-op proxies, BPSec cannot ensure the protection of application layer data between a co-op client and the co-op origin server, because the scope of BPSec would terminate or would start at the proxy. And in that case, OSCORE should be used to protect application layer data between the two actual co-op endpoints, at least if perhaps we cannot trust the proxies in between, which is, by the way, not yet in the text. Next, please. So in scenarios without co-op proxies, we state that both OSCORE or BPSec may be used to provide end-to-end application layer data protection. And perhaps an open question is, okay, is there any reason why both OSCORE and BPSec should be used simultaneously in some scenario known to be without a proxy? So if the answer is no, then okay, next question would be, which one should that be? And perhaps, well, BPSec allows to protect all the fields of the co-op message. So yeah, any input will be very much welcome. And next, please. Also, we've added in the section about IANA considerations the request to add the payload length option to the co-op option numbers registry. Next, please.
No, sorry.
Yeah, so there's just one more slide. Yeah, this one. It's about minor updates, section 4.1 on the messaging model for co-op over BP. We have now briefly explained that a request that carries the no response option from co-op, in that case, the co-op server doesn't need to send always a response. And in section 7, which is about observe, the co-op option by which a server may send notifications to interested clients following some target resource when there are changes in the state of the resource. First, we've clarified some text determining whether a notification was sent by the server later than another notification must be performed based on the creation timestamps of the encapsulating bundles. Formerly, we had a should instead of the must, and then a number of subsequent checks. So now it's much clearer and simple. And also we now cite the conditional attributes draft, which is a quite advanced working group document in the core working group, which allows a server to send those notifications only if some constraints are fulfilled. And that may allow to save a few messages and reduce the overhead. So yeah, I guess this is my last slide.
I'm in the queue, so I'm going to ask a question. Addressing your OS core versus BPSec without proxy example, and I haven't thought about this in great depth. I think both services supply slightly different security guarantees. So the OS core would run from the application agent to the application agent because it's protecting the payload, whereas BPSec is more often implemented BPA to BPA. So node to node would be providing that. It's not quite transport level security, but that bundle level security. So my answer to your question was it would be a deployment scenario decision, and having the capability of both is important. So in environments where they require BPSec for forwarding at intermediate nodes for sort of firewalling effects, very important to keep BPSec there. And the co-op applications themselves may require OS core for their own privacy needs when multiplexing multiple different types of services across BP. Final question is, with chair hat on, are you asking for adoption for this document? Because last time you said it's not quite ready. That's an open question.
Well, actually, our thoughts on this were to maybe in this next cycle, maybe before Madrid, to think about adoption. And then there are 2 working groups involved or in scope. And yeah, I guess we may need to discuss or ask chairs of both groups.
Okay, that's fine. And the chairs can help liaise with that and with the AD as well. So absolutely.
Okay. Speaking of, I think we have Eric in the queue.
Get out of the queue.
Actually, Rick asked the question I was going to ask, which is more like, what does core want from DTN? What should DTN do with respect to core? Right? Is it close to adoption? But it sounds like this will be worked out later. And the only other minor point is that I have since discovered that changes to ARPA don't go to IANA. Those requests go to the IAB chair. But this is a separate matter, and I have some other ideas for IP and DNS stuff, so maybe that'll happen somehow else, but just a little minor thing.
No, thank you so much. This is fantastic work, and again,
It's
quite
really
mature.
good.
Thank you.
Yeah, thank you.
Next, we're going to have a presentation on DTN reference scenarios. Is this Camilo presenting, or will it be Felix?
Yes, it's me presenting.
Would you like me to flip slides, or would you like to share your screen?
Can use the tool.
Both are fine. Maybe I can share if it works.
Is there a permission thing?
I think there's a permission thing. I have to wait for someone to request permission. You are requesting permission. Pass slide control.
Yes.
You should have control of the slides. All the slots for the requested media are already taken.
I just hit yes. I may have.
Have you clicked yes ahead of me?
Yes.
Ah, there we go.
Yeah,
Is this working?
We can see you and we can hear you.
Okay, great. I don't see the timer, but just let me know in case.
okay.
Okay, great. Thank you. My name is Camilo Malnati. I will present you the DTN reference scenarios I've been working on with Felix Flenge in the past months. Quick outlook on the agenda. I will introduce the scenario, explain the structure, show the 3 DTN scenarios we prepared, the file composition, so how we define them, and finally how we intend to distribute them. So quick introduction. So the idea of the DTN reference scenarios is to have is to allow demonstration and validation of bundle protocol and extension blocks, such as quality of service, compressed custody transfer, BPSec key management. And the idea is to have a common basis for validation and testing activity on those. So they abstract from specific mission and network topologies, but they still expose relevant characteristics in terms of data rates, contact, error model, etc., so that they allow meaningful demonstration and validation. So this is in context of CCSDS, and they are limited to what is reasonably expected in the next 3 to 10 years, especially with a limited number of nodes in scope. And they may not be sufficient for more research type activities, that especially if they need to address scalability, but this can still be a good basis for larger scenarios outside of the CCSDS scope. So we have 3 reference scenarios, one for Earth observation, one for lunar communication, one for Mars communication, with the following characteristic. we define a topology, data rates, latency, error model, and application traffic volumes for them. That are what we saw was the most important characteristic. So first scenarios, this is the Earth observation scenario, is the simplest scenarios with only five nodes. We have 2 ground stations, 1 mission control center and 1 payload center, and an Earth observation satellite. This is quite simple scenarios, but it's interesting because we can have parallel high and low throughput links with the Earth observation satellite. But what I think is a bit more interesting is the lunar communication scenario here, where we have 7 nodes on ground and 3 relays around the moon, one of which is the lunar gateway. So in this case, the orbits of the relay are representative, especially the lunar gateway has as the orbit of the actual planned lunar gateway orbit. And then we have 3 users, one of the on the lunar gateway itself, one lunar base at the south pole of the moon that is able to communicate with ground directly, and one rover on the far side of the moon that can only communicate via relays. The scenarios here, the images are color coded. So the idea is to have 2 agencies, 2 agencies or entities, one in orange, one in blue. And then here I have a small visualization of the links over time and how they look. So on the left, the Earth ground part, and on the right, the moon. So as we can see, the topology is still quite connected, and over time, the links are fairly long. That is different from what we prepare for the Mars communication scenario. That is the last one. So this is similar to the moon one, still 3 relays, 2 rovers, but in this case, we have much longer delays, and we have no direct with-air communication between the Mars ground and Earth. And in this case, as you can see, the simulation shows much sparser and quicker contacts. Okay. How do we define the scenarios? We have 3 CSV files and a mapping file defining the network behavior. So first we have a planned contact providing all the information related to the expected network behavior, an actual contact CSV providing a real link availability, an application data that provides the data volumes produced by the nodes in the network, and finally a mapping file that is more of an aid for a human readable mapping for debugging and topology setup. First file, planned contacts. There is an example here at the top, how does this looks. We have a source destination, contact start, contact end, data rate, and latency. So this file basically is targeting the bundle protocol agents of the nodes in the simulation, and it tells the BP agent when to activate and deactivate the CLAs. This is based on calculated visibility of the assets. So as I said, the orbits and the ground station position are realistic. So from this visibility, we can have some kind of mission planning, ground station planning, and pick the contact that makes sense in a mission. And from those, we have this file. So every line represents a contact. Fixed link are added at the beginning of the file and go for the whole simulation time. And from this file, we can completely derive the full topology of the scenario.
Camilla, can I interrupt for a moment to enter the queue? We had a question come in from the chat from Jorge Amodio to ask, why are we not considering the lunar base as a local relay for rovers?
This is possible. So we consider multiple scenarios. I think in this case, we wanted a rover on the far side because it's a bit more interesting and challenging especially for BP extension. Having it connected to the base constantly was not as interesting. But this of course can be expanded, and his scenario can be somehow expanded to your specific use case.
All right, thank you. And for time, we do have about 2 minutes left.
Okay. So actual context file is what we have applying an error model to the first file. So basically this tells the simulator when to interrupt the link. We defined an error model with some various parameters, so mispointing, weather, misconfiguration are the most prominent one. And from these we can apply to the plan context and say this this contact will not be available. So the BP agent will try to send data, but the link will actually not be available, in introducing error in the model. Last file, application data, provides the bundle generation and the bundle size so that each node, each bundle protocol agent application can produce node to inject into the scenario. And for simplicity, not all nodes produce data, but last file is the mapping one. This is a bit more of a work in progress. We are considering to use JSON for this one, and it's a bit of an aid to set up the topology and debugging. As I said, we are planning to have this fully automated, so with the JSON and easy to parse and then fully set up the simulation. I think this is the last slide, version control and distribution. So this reference scenario will be published as a yellow book in CCSDS, and they will be presented in the next spring meeting. The idea is to have for each scenario a major and minor version that will be updated depending on changes in topology, data rates, etc., so that they can then be precisely referenced in other work. And also an idea we have is would be to include configuration for these reference scenarios in BP implementation, so that this will allow for easier testing and interoperability. When you pick up an implementation, we will have a set of configuration basically ready, and this will also aid adoption of them. I think I should be in time, so are some reference for the work. As I said, I don't see the timer, so
that's time, Camillo.
okay, perfect.
Thank you very much. That's really useful. I've got one quick question. It's great that you're publishing the data in the yellow book. The formats of the data, are they standardized in any way, or are they just the convenient way of representing them in the yellow book? I'm just thinking in terms of other people producing other scenarios. Would you recommend they followed your formats as a well thought out way of working, or present in a format that works for them? How official is your format is the question.
Well, the idea is to have this published as an official format. So we are still, let's say, trying to gather feedback and comments on people using these, and try to converge to a definite format. As Felix is saying in the chat, the files will be published as well, probably in Sana. And fantastic. Yeah, if we have different format, then this will not aid interoperability, for instance. So it makes sense.
Thank you.
Good. Thank you so much. These are good scenarios, and cannot wait for them to be published in the CCSDS. Our next presentation is going to be from Felix on BP version 7 custody transfer and compressed status reporting. Felix, would you like to share your screen, or would you like us to share slides?
Let me try to share it.
Okay. So I have to share the screen. How do we approve this request? Control. Yes. Okay.
So
you should have permissions now, and
yes,
see your
it's coming up. Okay, so I would like to give you an update on our work on BPv7 custody transfer and compressed status reporting. This is an ongoing work with various people throughout the last 2 or 3 years. So on the agenda, I would very briefly just describe the motivation constraints and status, and then focus mainly on the custody transfer. We have a common mechanism called bundled sequence identification, which is used in both mechanisms. Talk probably just a little bit about the compressed reporting stuff, but very briefly also introduce what you can do with the compressed bundle reporting itself. So the motivation, of course, we wanted to have efficient reporting on bundle status. Yeah, for example, for us, it's very important to understand whether a bundle has been delivered or not at the final destination. You know, we don't like losing data. We wanted to have a custody transfer mechanism allowing opportunistic custody so that we can send a bundle and one of the nodes along the route is taking or not taking custody, and we don't want to be a need to specify before what is the destination, what is the next custodian of a certain bundle. We focus on immediate needs, yeah, similar scenarios we have seen this in Camillo already. Earth observation missions, very important use case for us due to high data rates. LunarNet, of course. So what we are doing should be suitable for small, tightly managed networks or single mission scenarios. Yeah, we believe we need to bring it into single missions as well to have a chance to have it really deployed much more widely. The Orange Book in CCSDS is 90% ready, I would say. Yeah, I'm quite positive that we will be able to publish this year. You will find that a lot of things are left to implementation. Because one thing is we needed some flexibility to cover the different scenarios. Another thing is that I think for some of the aspects still research and much more thought is necessary. Still, I think what we have is good enough to provide at least a basic level of interoperability. We have prototyped and evaluated early versions of this specification. I'm going to kick off the implementation of this version probably next week. Okay, so very basic concept. How do we identify, let's say, sets of bundles? We do this by introduction of bundle sequence numbers, which we qualify by bundle sequence ID. Yeah, these bundle sequence numbers are used in extension blocks or later in administrative records referring to these bundles, and they allow a unique identification of bundles during the lifetime. So there are also some rules on the rollover of the sequence counters. There are two fundamentally different bundle sequence IDs. Let's say we have the ID if it's non-zero, a positive integer. We can identify a bundle by a block source administrative endpoint ID. So this is the node which inserted that extension block, the bundle sequence ID, and the bundle sequence number. There's a special case, bundle sequence ID being 0. In this case, we use the destination endpoint ID and not the bundle sequence ID to qualify the bundle sequence number, because this is seems to be a very common use case and very useful in case you want to have delivery reporting. Some notes on how to handle these bundle sequence numbers. So the handling is done within the administrative element. And the assignment of bundle IDs is one of the things left to the implementation, because it's quite use case specific. So it can be the service number of the bundle originating service if you use an IPN naming scheme, if you like. Some people want to use it like this. It can depend on the next hop if you want to have reception reporting. This is more efficient. Or it can be the destination endpoint ID for delivery reporting, or you just use one or whatever you like. So now that we have these bundle sequence numbers, we define bundle sequences. This is quite straightforward. When we say a sequence, we have the first sequence number for that sequence. We have the length of the sequence, and then we use the sequence ID or the destination endpoint ID in case the sequence ID is 0 to fully qualify the bundle. For some cases, we need to have the block source administrative endpoint ID. For some other cases, we can leave this out, because if you use it in an administrative record going to that specific administrative element, it does know it's basically its own endpoint ID. Finally, a bundled sequence collection is a definite length array of such bundled sequences. So now we have a mechanism to identify the sequences of bundles. We can go on and define custody transfer. We do this by an extension block. Yeah, so custody transfer extension block has the following block type specific data. It has a bundled sequence number of that bundle, a bundled sequence ID, and the block source administrative endpoint ID, which effectively serves as some kind of the current custodian of that bundle. Yeah, we cannot have more than one custody block within a bundle. As a counterpart, we need to define the compressed custody signal, which is quite similar to the aggregate custody signal we had for BPv6. It's an administrative record. It's a CBOR map, which has a key, the disposition code. Currently, we define two disposition codes: custody acceptance, a positive CBOR integer, or custody refusal, a negative CBOR integer. There's room to extend this, and we experimented and discussed a bit having additional information in there. For example, whether if you refuse, you have forwarded something, or you have just dropped the bundle. But for now, we tried to keep it very simple. And the values themselves are then the bundle sequences we've defined before. So with this mechanism, we can basically say, I've accepted custody of this specific sequence of bundles. So now we still need to define the behavior of custody transfer. Yeah. Any node can request custody by inserting this custody transfer extension block. Any node receiving a CTAP and supporting custody in general needs to take a decision whether to take or refuse custody. And this decision is something which we see currently as implementation specific. Yeah, here some conditions are listed in here. It could be local custody, it could be learned, it could be just always take custody. And if you are the destination of that specific bundle, you need to take custody. So what does it mean to take custody? It means to store all the required information for creating the compressed custody signal. It means deleting the current CTAP. And it means before forwarding the bundle a new CTAP, requesting custody transfer with its own administrative endpoint ID as a block source administrative endpoint ID, which means basically replacing the previous custodian by the node itself as a current custodian. And it needs to store the bundle until the custody acceptance signal is received or the bundle lifetime has expired. If the node refuses custody, it needs to store all the information for generating the negative custody signal. So the signal itself, it's sent based on the stored information. The decision when to transmit a compressed custody signal, unfortunately, again, implementation matter. It can be based on timers, it can be based on size constraints for the custody signals, it can be based on external events, for example, establishing of a certain contact or an explicit command to send the custody.
Felix, I just have a quick question. If we could go back a slide to the custody transfer extension block, maybe 2 slides back. So here, yeah, well, that's fine.
No, it's that one, yeah. Sorry,
that's okay. The slide where we discussed the cases where we would delete the extension block. And my question is, in this work, has there been a consideration to the signing of that block and whether there would be a sense of approved custodians, as opposed to an interior node removing a custody block, adding a custody block, but not otherwise taking custody or otherwise not being a known or approved custodian? Is there an overlap here with security?
Yes, of course. Yeah. I mean, this is also the reason why we delete that block and cannot just change it. You know, we were not planning to change it. Maybe it's also possible for certain security context, but it can be, of course, target of a BIB in the end. Yeah, we didn't specifically look into all these cases, but it seems to be perfectly doable with VPSec.
Certainly. Thank you. And just before we go to the other question, we have about 4 minutes remaining for the presentation.
I'll hold my question to the end. That's fine.
Yes. So we do custody signaling. Yeah. So in case no compressed custody signal acceptance is received by a custodian for a specific bundle, the bundle should be forwarded. And again, this is an implementation decision. Yeah, you can use timers as we had in V6. They had some problems. Yeah, it can be based on received custody signals. There are a lot of situations where you can assume more or less in sequence reception of the administrative records. And so if you detect gaps or larger gaps, you can just re-forward. Can be explicit command-based, can be internal, external events, initiation of a contact, can be reported failure to forward the bundle via convergence layer. And there might be other things as well. Yeah, so we don't specify the way how you need to do it. We give some ideas, let's say. Compressed bundle reporting, I will do this very quickly. Yeah, compressed bundle reporting, again, is an extension block. It's administrative record. The extension block, in this case, it's a little bit more variable. You can have an array within, which can have 1 to 5 entries, and depending on the length, it means a little bit different things. Yeah, if you have the first 2 here, you see sequence number only, or sequence number with sequence ID. This is just used to provide to receiving nodes a sequence number. You can already do some interesting things with just the sequence numbers. The other ones, 3, 4, 5, are really requesting a report back, and there are different ways, basically, defaults depending on the length regarding where the report should go to. Yeah, we can have several of these blocks in one bundle. Yeah, here the most important thing is maybe what you see in the middle. So this is where you can request reports. You have the 4 reception, forwarding, delivery, deletion reports we have in the standard. We also thought it's good to add reports about fragmentation, reassembly, and regarding custody transfer. And of course, this can be extended in the future. And just important here, custody reporting should not be confused with custody acceptance or rejection. This is just reporting on certain events. So this is here's the full area. So in case you want to have a closer look. Yeah, so we here reporting is again very similar. You receive something. In case you have to create a report, you store all the information you need to have for creating that report. You might transfer it periodically, you might transfer it based on size constraints. And what you see here below is basically where does a report go to depending on what is the information provided in the extension block. Bundle fragmentation, I just say basically you cannot fragment a bundle which has one of those extension blocks because it creates a lot of problems. And we want to guarantee this by setting the bundle processing control flag accordingly. So 40 seconds for what can you do with that? Yeah, of course, if you just include a sequence number, you can do things at the delivery point. You can do in-sequence delivery of bundles. You can do duplicate suppression. You can do gap detection. So these are some things very similar to what we have with the payload. This is DTPC, the payload conditioning service. If you have reporting enabled, you can do end-to-end accounting based on delivery reporting, deletion reporting. Important, the source, the destination of the reports might be different node, might be interesting for network management purposes. Once you have the accounting, of course, you can also guarantee end-to-end reliability based on this accounting. So if you receive deletion reports, you can send the bundle again from the source, or if you haven't received the report, you should have received. So, done.
Done. Thank you, Felix. I'm going to ask a very quick question because I'm in the queue, and then I'll yield to Brian. first off, I think this is really interesting work. I think you have conflated three things into one document, which makes it quite tricky. The custody signaling, I think, is really good and is probably a piece of work in its own right. If this was an IETF document, I would suggest that was a draft that just talked about custody signaling, and I would welcome that as an IETF document. I think the sequencing of bundles is an interesting concept that I've not heard discussed before, and I think that's an interesting conversation for the wider DTN community to have. Is it useful to understand that the following bundles are a sequence, or is that purely a payload concept rather than a bundle concept? Open question, not expecting an answer. But my main problem is RFC 9171 defines a unique identifier for a bundle already. It's clearly defined in the document. And it's the combination of source ID and the timestamp plus fragment info if it's a fragment. And that is clearly defined and used across all of BPv7 as the, how to remove duplicates, how to do reassembly and so on. I don't understand why you've introduced a new ID concept as an extension block.
This is very easy, because with the new concept, you can have really these large sequences of bundles, can refer to them in a very efficient manner. A few bytes. Then if you would have to include a list of all these timestamps and everything, it gets very large. So this is for the efficiency of the reporting.
So it's purely to reduce the overhead of the length of the lists that make up a sequence. You're introducing a new integer number rather than using the combination of EID, timestamp plus optional fragment, which can be, I know from experience, quite large. 40
and it's very
60
important
octets.
because we quite have this on the uplink, and with that we can have an enormous reduction, which is really required. It also facilitates let's say, storing of this information internally.
Okay, so I'll rephrase my previous statement to say I think there are two concepts in this document that ideally from an IETF perspective I would split apart. One is the sequencing, which I think is an interesting conversation to have, and the use of a new ID. And the other is the custody signaling, which I think is really strong.
Yeah, just to say, we have it included in a single book currently just for kind of practicality, that it's easier to publish a single book. And once we have done this, of course, we can discuss how to go on with that. It's also possible to go with 3 RFC into IETF and so on. But it's more important for us currently to get it out there very quickly.
Just in the interest of time, Brian Sipos, a quick question?
Yeah, just one question, comment. Is there a consideration for having compressed reporting with a range that has gaps in it, or a discontinuous range? Right now, the technical definition allows only a single interval.
No, and I think it's much more complex, and it's not such a likely scenario, but we can talk about this certainly offline at some point in time.
And then just final, Felix, this is good work, but I don't know that this document is available to everyone on IETF. If it is possible to post a link to where this work would be publicly available, we would welcome that on the mailing list for those who want to go back and look through this in some more detail.
Yeah, I mean, this is one of the reasons for the presentation. The presentation should contain all the technical information which is ready. And for the document, we are currently looking into ways to make these things more easily accessible. Okay. Right. But you have all the content within the presentation.
Excellent. Thank you very much. Great. Our next presentation is going to be Scott Johnson talking about interplanetary DNS. Scott, would you like to share your screen, or would you like us to share in advanced slides?
I'm sorry, can I impose on you to advance the slides for me?
Of course.
Okay. Thank you very much.
All right, we are so sharing. Please begin.
Okay. Hi, everybody. I'm Scott Johnson from Spacely Packets. Today, I'm going to introduce a draft that seeks to create a coherent model for interplanetary or solar system internet naming. That draft is titled on the bottom of the slide there. Next slide, please. So this entire concept is predicated on the thought that IP networks of some utility will arise on otherworldly bodies, be they the Moon, Mars, Europa, wherever we happen to go, and we want a coherent naming structure that works essentially in all locations in which we have IP networks deployed. In order to effect this, we're going to go over just a couple of basic tenets of the concepts here today, including the concept that discrete DNS networks per world are necessary to support local operations on each world. This means, well, I'll get into that in a minute. As well, discrete top-level domains per world are preferable, but not strictly necessary to achieve interplanetary interoperability. Another topic that I'm going to broach today, but is not strictly well treated in the draft, is the IPN DNS resource record type that has been created and is in the IANA registry. Slide, please. Okay, so discrete DNS networks per world support world local DNS operations. And fundamentally, this means that we don't need any data exchange, no zone transfers, no updates, no refreshes across interplanetary space or between us and the moon or wherever. This creates a distinct DNS route on each world that we visit to allow for robust local DNS service. This is not useful unless we have services which are using DNS. And so in this model, interplanetary network service interoperability is provided by an IP to BP and perhaps back to IP application layer gateway architecture. The distributed multi-route DNS model overcomes the delay and disruption plagued environments by keeping all queries local to the world in which they originate, and queries which would seek to find off-world resources are directed to a service-appropriate application layer gateway for processing an entry into the BP network. And when I say service-appropriate, I mean, there's a handler for SMTP, there's a handler for HTTP, there's a handler for rsyslog and similar. Next slide, please. Okay, so when we're talking about discrete DNS networks per world, this also means that there are discrete root zones on those networks. The top-level domains in this model remain identical through any implementation of DNS on any world. However, the contents, the data that is in that DNS will vary by locality, and particularly in the root zone. One of the reasons that I'm hoping for work group adoption of this is so perhaps we can make a better name than the already kind of defined stub zone in DNS. But the concept is that we have a truncated set of data that serves off-world domains on any given DNS network. So we want to limit those resource record types that are represented in those zones with MX, CNAME, name server, IPN, or text records, and there may be more that are applicable as we begin to explore this. But the concept is to strictly and explicitly prevent those records which represent IP addresses or AAA records, in other words. And the reason for this is so that we can have logical routing as well with dedicated blocks of IP addresses that exist on other planetary bodies. We don't necessarily want to expose the existence of those addresses or the routes to those or potential routes to those through the system, and it does not do that. A logical naming convention places all lunar networks, for example, under one or more dedicated lunar top-level domains. So we would have .moon or .mars for Mars or .europa or Europa.Jupiter, perhaps. in order to name those resources. However, we can use existing second or third level domains from the existing TLDs to name these off-world resources. This kind of works as long as the records that represent a given domain follow the rules as described in the stub zone. However, this can cause kind of ambiguity in being able to quickly determine where a domain is. That might be a feature, I don't know, that ambiguity. But it would also require greater diligence on the network operators and DNS operators to maintain a sane configuration if there's not an easy differentiation between on-world and off-world resources. Next slide, please.
And while that slide is loading, you're at 350.
Thank you. So we have the new IPN resource record type. I know Rick was particularly interested in this when I was making the creation of this in the IANA database. Now is the time that we have the opportunity to review, amend, and modify this. Basically, the IPN records enable the naming of any bundle protocol related network resource, free-ranging spacecraft, application layer gateway hosts, remote BP enabled edge nodes, or any terrestrial or extraterrestrial overlay participants in terms of host or node. So anything that has a BP name, or yes, a BP name, expressed as a node number or node number and allocator ID pair, can be represented by this resource record type by doing an IPN resource record type lookup, as opposed to, say, a text or an NSEC or an A record as we normally use. The definition of this does need a little bit of updating. Presently, it only considers the 2-element EID scheme. However, that's backwards compatible with the 2-element encoding of the 3-element scheme. However, it would be nice to support the 3-element scheme directly as well. This has been implemented and successfully tested with the same functionality as a text record, which is more than sufficient to do the job. However, this group, I imagine, may want to optimize these records in one or more ways. So we can do that by amending the original draft that did this. We can do this by standards action in this document, if this document is taken up by the working group, or other work group action. I mean, you guys know better how to affect these changes than I do. That's just the ways that I know. Next slide, please. Okay, so this is, I'm not going to go into this in detail. This is a diagram of an implementation of SMTP that uses this DNS architecture to affect its job. This is implemented in the real world with luna.sol.int, which is a BP-only connected host that can send and receive emails to the public internet. I point to it here simply because if you follow kind of the red lines and the green lines, red on the left, green on the right, you'll see that no name server lookup has to leave its local internet segment. This overcomes the delay and disruption. Next slide, please. Okay, so, you know, eventually when we have people in other places, they will be extraterrestrials in one form or another. And so I would like them to be able to phone home or at least email home or perhaps do a lot more back to home using standard internet tools that they already understand. I'm asking for workgroup adoption of the document at the URL at the bottom. And I thank you all very much for your time.
Scott, thank you so much. We do have 2 folks in the queue, starting with Eric.
Thank you. Can we go to slide 4?
Eric, can you raise the mic slightly?
Yes, I guess. So, yeah, I mean, you allude to this in your document, the fact that this is not going to work with the NSSEC, and I actually think this whole thing is kind of not the right approach. I don't think we should be hacking DNS. We have. I think it's probably better to distribute. I mean, for example, there's already a bunch of root zone operations to just distribute the science zone, and we could, you know, find ways to publish that over bundle protocol to the far reaches, and also other related zones. I don't think this filtering strategy is going to survive operationally. Go ahead.
Do you want me to respond point by point, or?
Sure.
Okay, so DNSSEC is
We
not
don't
broken.
have much time. I'll take this on the main list, I guess. If we have an adoption call, I'll for some stuff. I guess, I mean, we have like CDNs. We have other ways that clients can learn what they can and can't have. I think we should have IP addresses, because if you're in a lunar zone and there's an IP address that is reachable from you, you should be able to get it, and a bunch of other stuff. I think there's other.
Yeah, I agree with that. However, this model does not break DNSSEC. It simply segments DNSSEC because there are discrete root networks that are essentially isolated chunks of the internet.
If you don't have the whole zone, you break DNSSEC, because you can't do negative. You can't do NACs, right?
There's no packets that are passing over the bundle protocol network. So I don't understand how, if all the DNS queries are isolated to one area or one section of the network, how DNSSEC is broken if there is no DNS query that needs to happen across the void.
So let me just jump in, just because we are very, very over time. But what I'm taking from this is that there are questions. We should absolutely take them to the mailing list, and that would allow us to respond in time and with detail.
Thank you very much.
Happy to. Thanks, Eric.
So, Rick, chair hat off.
Yep.
I absolutely support what you're trying to do. I think sorting out DNS and how this works over multiple planetary bodies, how it interrelates between BP and native IP networks on whatever interplanetary body or remote destination is vital. I think it's an important building block that we have to get right. I have technical questions about the detail proposed that I would love to explore further on the mailing list. So 50%, yeah, love it. 50%, and I want to argue with you about it on the mailing list.
Yeah, put on the mailing list. So our next set of slides are the status of the network management work, delay tolerant network management architecture, presented by Jenny Cow. Jenny, would you like to share your screen, or would you like me to slide flip?
I'd like you to slide flip, please. And yeah, I can go through this relatively quickly, and then if anyone wants more details, they can always ask questions since we're behind them. Next slide, please. So I'm just going to cover the latest updates to the DTN drafts, which we have 4 of. So for the AMM draft, the latest update just clarifies conditions for built-in types and some processing activities, such as how to handle undefined value, particularly with given parameters. And it also explains how we've made the decision to break down the namespace into organization ID, model ID, and model revision for ADMs. And there are just some places where there were normative references to the AR draft that have been removed, so that there's no longer a circular normative dependency. So now all mentions of the ARI draft in the AMM draft are just purely informative. For the ARI document, the latest update talks about the namespace breakdown and also has an initial table of well-known organization registrations. It also clarifies the domain of integer enumerations and text names for identifiers. The ARI also now allows for model revisions in the binary form in a manager, but not to or from or within an agent. And there will be a note about this later, because agents only implement one revision of an ADM. And the ARI UR scheme is now under provisional registration with IANA, pending RFC publication. And if you go to this presentation, there's a link to that. For the Yang syntax document, the latest update just makes some clarifications on what is directly reused from Yang, and also includes updates to the embedded ARI namespaces. For the AMP document, which just details a binding for ARI onto BPv7, and includes requirements on source authentication and data integrity, the latest update was just to include examples of ARIs and AMP messages. Next slide, please. So this is just a diagram showing the normative references. Before, there was a small but still an arrow from AMM to ARI, and so that's been completely removed. And so now that circular normative dependency has just been removed. And you can see the relation of our 4 working group drafts to the our DTN RFC and other RFCs as well. Next slide, please. So just to expand more on the namespace logic, Every ADM and ODM has a unique namespace. And again, these have three components, an organization ID, a model ID, and model revision, although the model revision is only for ADM. The organization ID can either be well-known, IANA registered, or private use. And the model ID is either an ADM or an ODM. And if it's an ADM, it could be registered with IANA. The model revision part is only used for ADMs and also only by managers, as again, an agent can only implement one revision at a time. And so this is used by the manager just to disambiguate between multiple revisions, as an ADM can have multiple over its life cycle. And there's also just an example showing what the form would look like and what the binary form would use for the secret tag. And these are examples for ADMs and ODMs. You can see how the revision is only included in the ADMs. And also you can see how it's the example in the first line, the example is the well-known organization. And you can see how that is a clearly separated part from the ADM name, which would be ADMA. Next slide, please.
So for the organization registration, the current AI draft includes
an initial table. So you can see here for the well-known organizations that we've established right now are just IETF, IANA, and example. So it's split between the negative values, which are all reserved for private uses and experimental use, and then the low values, 3 to like 65,500 something, that is reserved for expert review, and then the higher values are for first come, first serve organizations, public use. And this is similar to the IPN allocated registry, but obviously just provided. And the expert review organization, we expect to have allocations for TCSCS and SANA, and because we expect from different places, we don't require a specific external review specification. So IETF is for the ADMs with behavioral objects. So we have IETF AMM and IETF DTN agent. We have IANA for code point definitions, so ident and type def objects, and the example is for documentation. Next slide, please.
So now just to discuss some issues and work. We just need
to make the namespace reference a full member of the built-in AMM type system. And we're thinking of removing the type defs from the IETF AMM ADM, so it's separate. So the AMM ADM would just be purely extension keywords, and then the type defs can be moved to IETF AMM types ADM, and then the IETF INET types and BP types could be for IP related and BP related types. And finally, we need to do more work on what ADMs will be importing other ADMs. We just need to sort of design that more because there's not any confusion over what to implement with ident and type def, but just in what ADMs they reside and how they would relate to each other. And then we also would need to make a clear preference towards what modules would be optional. For example, if someone's not interested in implementing IP or DNS names, then they don't need to use the INET types module. And that's all. Any questions?
No.
No, Jenny, thank you very much for this. For those who have not looked at these drafts, these are adopted working group drafts. They are, I think, getting to a point of maturity. So I would ask that we get some review and any questions on the mailing list.
Can I add that the chairs, with the assistance from the AD, is trying to circulate a lot of the Yang specifics, particularly around the domain-specific language encoding within Yang, with the relevant Yang experts within the IETF to make sure that we're meeting their expectations of how you encode a DSL, which is a very corner case of Yang that causes raised eyebrows every so often, just to make sure we address any perceived issues prior to getting to an ISG review and slowing down the process.
And in fact, at NetMod, at this IETF, there will be a presentation of this Yang model.
Yeah.
All right, Jenny, thank you so much. The next presentation is an omnibus discussion of a few working group adopted and personal drafts from Brian Sipos. Brian, would you like me to move slides, or would you like to present?
Go ahead and bring them up.
Can do.
So this is going to be pretty short with a little bit of time for discussion, I hope. If you could flip to the next content. So this is a list of the current working group drafts that are being edited one way or another. The most mature one to the least mature one is the BPSec COSE context. And I'll have a separate slide with open issues on these things. This is just a summary of the current state. But the good news, at least on the COSE context, is as written, it's a stable definition, and there has been a couple of trial implementations interoperating, which is good, proving out that the content definitions are what they ought to be. There is one open issue that is linked to on the mailing list that I intend on addressing about covering the security source as authenticated data. And my thought on that, I'll cover it on a different slide, but my thought on that is just to always include this as authenticated data because it's always going to be present anyway. So on the EID patterns draft, this also is now at a stage where I think the definition is stable, and there have been a couple of trial implementations of earlier revisions. I don't know about the latest revision, but the last changes actually were to make some clarifying statements and to make some optimizations that I'll discuss in a slide. And the major change in the last revision is to remove the DTN scheme as a consideration for the current definition of the pattern, just for scoping and simplicity of getting something done and having a framework for eventually adding back in a DTN scheme when the structure is more well understood. On the topic of the revision of the UDPCL, this has had a trial implementation of all of the features in there. There is an open question that I would love to get some feedback on, which is which of the features are valuable, which of the features belong in this specification, and which features can be deferred to add-on drafts. The mechanism for extensions right now is a map with integer keys, so we've got a whole variety of what could be there, and not all of them need to be in the core draft. So it's just a question of what's worth including and what's not. But I believe as it's written right now, all of the extensions are implementable and have been trialed to show that they're doable. And then this becomes a question in the same vein as there was earlier discussions on other drafts of the difference between things that are mandatory to implement, optional to implement, but everything is optional to use. That's the main point of all of these extensions. And there's a somewhat of a relation to the DMUX draft that I linked to in the PDF, and the zero configuration draft that I'll talk about in a second.
Brian, can I just very quickly jump in, because I'm in the queue, about the DMUX draft? I am very happy to stop working on that and yield all the discussion and so on that went into DMUX into the UDPCL, because I think it actually makes sense to have that information in UDPCL and probably doesn't elsewhere. I don't think it's a standalone draft anymore, but I can have that conversation.
Sure. And yeah, and that is an interesting point. And this also relates to that unidirectional draft that's been brought up, in that there are some overlapping features of these things, but the details do tend to matter for the specific transport being used, just because in the case of UDPCL, we have to disambiguate not only bundle types, but also if somebody is intending on using DTLS, we don't want to collide with those code points.
Indeed.
Meaning we would prefer to avoid having ambiguities, because that makes life very difficult for any implementation. But I will bring up that the UDPCL draft has been adopted. So this is now an IETF labeled draft. And both the UDPCL and the next one I'll talk about, SAND, we have co-authors, which is great. So Josh Deaton from NASA has volunteered to edit these out. So on the topic of the secure advertisement and neighborhood discovery, beyond just being adopted, this is a first attempt at defining what this kind of mechanism can look like. The goal here is to make it open-ended in the same sense that there are some other existing advertisement mechanisms for MANET and for some other routing areas. The intent is that this would provide a means for other node information, other interface or link information to be able to, in some sense, piggyback on top of this encoding. Not as a required way, you must do things in this way, but if you already have an implementation, it significantly will lower the barrier for how do I get this information from my node into my neighbors that care about it. And just as a reference, this does depend on the base definitions depend on the UDPCL, an IMC multi-point scheme, which is still TBD, but coming out of the CCSDS as an experimental book, and EID patterns. Next slide, please. Go ahead.
Brian, sorry, it's Rick again. I'm going to jump in quick. I think some of the stuff for the BTPU also has properties, much like UDPCL, the ability to broadcast to multiple receivers that is applicable for SAND. So I'd like to have that conversation as well to see whether there's generics above, oh, you can do this with UDP. It's actually, you can do it with anything that can broadcast.
Yep, that's absolutely true. And that is also the point of this layering, which is what makes it a bit distinct. Well, not a bit, does make it distinct from the earlier IPND, which is IPND combined everything together and it all had to live together. And in this case, like you mentioned, you can absolutely implement this messaging on top of any CLA, and even multi-point destinations are not required by the CLA. It's another one of these things that if it's helpful for your deployment, you can use it. If you have neighbor information that's coming from somewhere else, the radio itself is telling you a link is available, a neighbor is present, you can use that as well. So if that, and this is something that's worth having some feedback, because if that isn't clear from the current draft, which is very drafty, that's the kind of feedback that would be helpful. Next slide, please.
2 minutes.
So this is, okay. This is open discussion points that I was talking about before, and I'd like to get some feedback on, just to know that there is other eyes observing this stuff. The COSE context one, I'm of the mind of just doing an update and then seeing what people think about that. I think it's a pretty straightforward update, but it would address this one particular issue that's an open gap. The EID patterns, there is now a shortcut defined so that the maximum value has the actual word MAX, max, as a placeholder. The technical definition doesn't need to use this word, but my thought is that having a character sequence in there as a sentinel for that purpose is better than an encoding that takes the absence of some symbol as the presence of some meaning, but that's just my personal preference.
Sorry, Brian, I'm going to jump in again. I meant to reply on the list because I had a thought about this. Why not just use a plus? Just use a plus symbol.
Yep, I don't have the strong feelings, so if somebody, if you have some feedback or some preferences or some rationale, yeah. And then, like I mentioned earlier, the UDPCL and SAND haven't received any specific feedback. So if anybody has opinions, issues, that would be good to bring up. The good news is that this stuff has been prototyped and is available as a reference implementation, just to see that it does do the right thing. And the other benefit of both of these things, and also the unidirectional, is that these things have very simple state machines. So the goal is that these are not complicated protocols. These are means of conveying data. Next slide, and I think this is the end. I'll just mention that the zero configuration draft still exists, and if anybody is interested in treating this as part of their implementation, doing a prototype, this has been proof of concept implemented, and I think there's value in situations like a hackathon where people just want to plug things in and make them work, and this is a way of achieving that without spending a half of an hour trying to configure your node. So that's the end of my slides. Thanks.
Brian, this is wonderful work. Thank you so much. And like we heard a few times here, let's take some of the questions and replies back to the mailing list. Next up, we have Rick.
Me. Oh, I'm tangled in cables. Oh. Can you share and do the thing? Does the clicker work?
It does not.
Okay. Hello. I hope you can hear me. So I'll go fast because we're running short on time on this one. So I pushed out 2 now personal drafts on what I'm calling bundle transfer protocol unidirectional. Next slide, please. So having looked at the problem space, there are quite a large number of link layer protocols out there that work in terms of frames. You know, these are RF layer, there's a little bit of digital signal processing that happens on top, chunk it up into frames and shout over a certain part of the spectrum. USLP, EPP, SPP, TM, AOS have all been defined by CCSDS. Some of them have more structure and some of them are really very simple framing. DVB, S2X is an example, but most of the DVB suite is fundamentally large binary frames running over raw RF. The same can actually be applied to, say, 5G PDUs are pretty general. They have a frame level size, they're delivered across the network. Ethernet, again, is another example, but they have characteristics. They're roughly frame-based. Some of them have variable length framing support, but if you look at it closely, you'll find it's actually mapped down to frames with a bit of implicit padding or explicit padding. They are unidirectional, and this is quite important. So there is no in-band return path. You may have a second channel or a second mechanism in place which will trickle something back, but I am considering those as 2 separate paths. So I'm concentrating for BTPU on that unidirectional transport. They're also fundamentally unreliable. So because they're running over RF and there is no return path, there is no acknowledgement mechanism built into the link layer. If you weren't listening, you don't hear it. But if you read through the document, I make a small proviso. There may be some mechanism at the receive end to know whether you got a complete frame or you don't get a frame. The idea of getting a partial frame or a broken frame is left as a mechanism for the link layer. So CRC kind of concepts, that's a link layer property that's expected. And the fourth bullet actually is these are in general point to multipoint. They are often provide a point to single point, but they may be point to multipoint. So disregarding point to multipoint, and this was the main change between draft 00 and 01, was actually underlining these things were multipoint. So you need to understand that they can be multipoint optionally. Next slide, please. So what is BTPU? Because there are all these link layers that have this commonality, we can develop a convergence layer protocol, and thank you, Scott Burley, for drawing my attention to the terminology here, which is a very thin layer that can be used by a convergence layer adapter to run bundles over these link layer protocols that have this common functionality. So it's a way of handling the fact that your link layer has the characteristics I've just defined, but provide a bundle service to the upper layer bundle protocol agent. So you can be a CLA if you implement this CLP on top of your specific link layer. Important note, you can actually carry any blob you want. It was designed for BPv7 bundles, but you can stick BPv6 bundles, you can stick cat videos in there. I don't care, they're just large binary objects. Next slide, please. So I say we, it's me, although in discussion with a number of other people. We're not reinventing the wheel here. Really are trying to keep it really simple. So first off, it's TLVs. It's binary encoded TLVs in network byte order. Go look at every IETF protocol that's been successful out there, and you'll find at some point it's got TLVs in it. So if you don't know what a TLV is, ask around, or I can talk to you afterwards. Basically, you break all the correspondence down into a sequence of messages, and you then pack the frame with those messages with an extra message which allows you to pad. So therefore you can do that bin packing of well-defined self-describing messages in a TLV format. Second property, bundles are bigger than frames. Therefore there must be some mechanism to snap a bundle into smaller parts and pop it into those frames and reassemble it at the end. This is not bundle fragmentation. This is what, copying from TCP/CL terminology and UDP/CL terminology, this is segmentation, and it's literally cut it into slices, record which part of the total that slice is so that you can reassemble at the end. Really simple. And the third thing is, because the receiver cannot tell a sender it got it, there has to be some synchronization mechanism, and the synchronization mechanism is a sliding window. And I'll come on to that in a little bit more detail in a second. So I also provide two extra optional mechanisms to add a bit of loss protection. Number one, you can repeat messages. So if you want, you can take your bundle, snap it into chunks, and repeat every chunk multiple times, trying to up the probability that the receiver got it. Pretty dumb, really simple to do. So it's there. Equally, if you don't describe what happens with duplication, then your specification isn't very good. So it was worth writing it anyway, so it is explicitly allowed. And the second is forward error correction. So that's full FEC support, and I've got a final slide on that. That's a second draft because it's complex and it's optional. Next slide, please. So messages, I've done this before. TLV, I've just said about this. Everything is a TLV, everything has a common header. It gives you extension points. It means parsing at line rate is desirable and possible because it's really simple. It's the kind of stuff you can go and write in VHDL and pump into an FPGA. Next slide, please. Segmentation. Again, take your bundle, snap it into chunks, encapsulate each chunk in, segments. Break it into segments, put each segment into a message, put the messages into a frame, pointed out of the RF emitter. Off it goes. So a very simple scruffy diagram of 3 bundles of different sizes. The first bundle does not fit in a frame, so we break it into 2 segments. Segment 0 and segment 1. They have a transfer ID. The transfer ID is how you can reassemble that transfer is made of 2 segments. The second bundle, B, luckily, fits in the frame, in the space, including the previous segment we've had. So you don't need to segment it. You can just go, here's a bundle. Really good when you've got small bundles with status error reports or things like that. You can just slap it in, no manipulation required. And again, and you can work through this. This diagram's in the drafts. Next slide, please. Transfer multiplexing. Okay, so if we've got segments bound together with the context of the transfer ID, can I have multiple transfers in flight at the same time? Well, yeah, it's quite important that I can do that because that means I can avoid head of line blocking. If I have some kind of higher level bundle protocol prioritization and I have a massive low priority bundle that's queued up for egress and suddenly a high priority bundle comes in, I need to be able to pause the segments I'm transmitting of the lower priority one, or possibly even cancel it, depending on policy, in order to start transmitting the higher one, and then resume with the lower one. This diagram isn't actually very good, and I want to redraw it because the top of the stack thing bundle, you would already be framing up that first link there, PDU, while bundle B arrived. I need to redraw it, but you get the concept, I hope. Next slide, please. Sliding window. Okay. The sender and the receiver have a pre-agreed, i.e. pre-configured a priori configuration or some out-of-band mechanism to say the number of transfers that can be in progress at any one time is W, the window size. That is a sliding window. So when you receive a newer message with a newer transfer ID, and that window is for transfers, not for segments, it's for transfers, you increment your sliding window, you move it forwards as you receive new transfers beginning, and you therefore cancel the things which drop out. If you have a long period of silence as a receiver and suddenly receive a new transfer that could be 16K, a couple of million ahead, this is a 32-bit number, you can skip forwards in time. So you can have 8-hour silences with gigabit links and still resynchronize fast. And that's well defined, and there's a bit of pseudocode in the draft to describe how you would detect whether something is a very old message or you've been asleep for a long time and woken up, and how to move your window correctly. This is critical to allow non-transmit capable receivers to stay synchronized with a transmitter who cannot receive. So it's how to keep things spooling forward successfully without on a unidirectional link. Next slide, please. Repetition. You can repeat stuff. It's fine. It's all good, but take into account the sliding window. Next slide, please. I'm going fast here. FEC. So bless the RTP IETFers. They have written a fantastic framework in RFC 6363, and it's been updated by some other things, and it's got a bunch of supporting drafts on the real technology. It describes a framework originally developed for RTP, but has now been generalized to be generic across, and it is entirely applicable to what we're doing with BTPU. So if you want FEC, and it supports Raptor, RaptorQ, LDPC Staircase, Reed-Solomon, RLC, it's got all the support, fully defined, really nice encodings of it, lots of flexibility, lots of good mathematics behind it. So it's all provably correct and implemented elsewhere. We can just use it. And if you don't want to use it, you don't have to. One comment on FEC. If your link layer does FEC, you should probably use your link layer FEC, because it has a better understanding of what's actually happening at layer 1. If it doesn't, here's a solution which doesn't involve inventing a whole new 23 extra RFCs. I don't want to write those. I'm not a mathematician. Other people have written them. Next slide, please. Okay, so I've got the base BTPU document written. I've written the FEC document. I'm about to write BTPU over Ethernet. I'm looking to liaise with Tommaso kindly offered that DLR are doing some clever things and know about DVB intimately. I want to write a DVB profile for BTPU. How do you cram this into DVB? One of the relevant flavors. I'm collaborating with someone within 3GPP at the moment to get this specified over 5G PDUs. So that's bundle over 5G, 6G. And also liaising with CCSDS to get this stuff properly written up, possibly as a colored CCSDS book or as an IETF draft, completely open to suggestions there for the various CCSDS link layer protocols. Next slide. The end. Any questions? That was very, very fast. I'm happy to take long questions on the list.
Yeah, I would say just in the interest of time, let's take questions and review the list, but thank you, Rick.
Thank you. And next up, we have Ed.
And next up is me. Hi. So in the interest...
Do you have slides?
I do have slides, and they should be. So in the interest of time, I'm going to present this in just a few minutes, but then ask that as we create some topics in the mailing list, we migrate the discussion there. The topic that I was going to talk about was we're calling RFC 4838 biz. So RFC 4838 was the original document out of the DTN research group that defined delay tolerant networking as a set of networking based on a bundling layer. Next slide. So the history of that document as it came out started with 00 in March of 2003, and it resulted in 4838 being published in April of 2007, which, if my math is correct, was 18 years ago. And so things have changed. Some things have not changed, and some things have changed. And we would like to create a biz for this to relook at what was driving the bundle protocol messaging, and what we are seeing coming up to date. Next slide. So for that reason, we reached out to many of the original 4838 editors. All of them were willing and excited with the idea of putting a new version, an updated version of this document out. And there were a couple of key questions related to that. I wanted to pose those 3 questions here. Happy to answer quickly any questions, but otherwise to bring this up to the mailing list. Next slide. The first, of course, is one that we are looking now at space networks in the past 5 or 10 years, and we're looking forward in the next 5 or 10 years at building lunar networks, Mars networks, near space networks. We have near space networks that are running, and there are questions architecturally about what do we need and how much store and forward do we need, and what is the purpose of things like a bundling layer. There was a document written by Scott Burley, the link is here, Draft Burley Deep Space IP Assessment 00, where he worked through some of the things that he felt were necessary to be incorporated. I know that in the Tip-Top working group, this is being worked and rolled into an architecture description for space networking there as well. And as we start looking through these, there are some things, at least in this deep space assessment, that also speak to the need for things like store and forward as our space agencies have interpreted it, then the need for things like bundle protocol and that set of knowledge of what space networkings need to be doing and what we know those difficulties are going to be probably should be part of an update to that document. So what I would ask in the working group, and we will post this to the mailing list, is please review this and let's make a discussion topic to see what, if anything, we think should be carried from this into a 4838 biz. Next slide. As we then start looking to things that are inside of 4838 biz.
Sorry, my laptop lost the Wi-Fi.
No worries. There are a few things that we know are very different from the original 4838. Some of the discussion around security has been overcome by events with BPv7 and BPSec. Additionally, something that is needs to be treated a little bit differently are the ideas of quality of service, the idea that a bundle would assert its own quality of service and that would be honored by BPAs in the network is possibly not the mechanism that we want going forward, because we understand particularly in stored forward networks and time variant networks, quality of service parameters may change over time. And then separately, custody transfer, how we have discussed it. We heard from Felix earlier today. We have other presentations around the idea of convergence layer adapters for reliability and custodial transfer. We do feel that there needs to be a good definition of what that concept is. And maybe custody transfer is not a single mechanism or a single protocol, but an emergent property of many things working together. Next slide. Finally, there is a renewed focus and understanding around bundle fragmentation and reassembly, and whether reassembly should be simply the reassembly of the original payload, which is ADU reassembly, or whether it should be reassemble of the entire original bundle, and then having reassembled the bundle, locally deliver it and its PDU for end state security processing. So much of the discussion on fragmentation and an idea called reactive fragmentation, which was in 4838, probably also needs a significant revision. So I'm sure that we all have significant opinions on the technical direction of this. I wanted to make the working group aware that a 4838 biz is something that is going to be proposed, that we have some initial thoughts on it. We should see a 4838 biz internet draft coming shortly. And for all of the discussions that will come from that, please read it when it comes out, and please be vocal on the mailing list. It would be much appreciated. Thank you.
Thank you very much, Ed. I see no one in the queue. Moving on.
Oh, so then next we have the bundle protocol quality of service extensions. Speaking of bundle protocol quality of service, with Teresa. Teresa, would you like to share your screen, or would you like us to work through the slides?
I would like to share my screen, please.
Certainly.
You're going to click the button.
I can try and click the button. There we go. I click the button.
Oh. I cannot share my actual screen.
Ooh, let's try this again. Okay. Let me know if that is working.
I have the slides control, but I cannot share the slides that I have open on my computer.
Okay. Well, then perhaps I will share the slides, and then we will go from there.
I believe I haven't sent you the slides because there was a very sudden change to the agenda.
Well, in the interest of time, why don't we move to the next one, and then we'll see if we can look at the technical and then come back after?
Yes, I will send it to you meanwhile, sorry.
Okay. Or do you have them?
Let me check.
Right. Let's move on to key establishment in the space environment. And then from there, we will come back to quality of service. All right. And Benjamin,
Hi, thank you.
Pass slide control to you.
Thank you.
I would ask if we could hold this presentation to 10 minutes to give Teresa some time at the end as well.
I will try my very best. In the interest of time, I will get started. Okay, cool. So good day, my name's Ben. I'm here to talk about key establishment in the space environment. Okay, so the terrestrial internet as we know it operates under certain assumptions, and these assumptions made about the terrestrial environment are violated in the interplanetary and especially in deep space communications. So we can see here that we highlight the differences between the two, such as a lack of continuous availability of nodes, the overhead in terms of latency introduced by significant distances, this higher probability of packet loss, all of which leads us to the observations that session establishment handshakes can be unreliable. So this means that the choice of any key exchange mechanism has to be chosen carefully, especially in protocols where packet loss can incur further delays in key establishment. So previously, our team has looked at the bundle protocol and more specifically the security guarantees of the BPSec protocol. I'm going to really quickly go over our results, our interpretations, which motivate this presentation in particular. So here's a generic bundle message consisting of 3 types of blocks. We have our primary block, which broadly captures header information. We have our payload block, which contains the actual data that's being communicated. And then we have our extension blocks, which is where the magic really happens in terms of security. This is where we leverage the extension blocks to integrate security in BPSec, specifically integrity and confidentiality guarantees. So extension blocks, and specifically DIBs and BCBs and BPSec, provide integrity and confidentiality guarantees for the BP protocol. Here we give a description about how these are constructed, which I won't cover in depth here. What I really wanted to note here is about the use of the keys. So keys are used to provide authenticity guarantees via MAC tags, or they're providing confidentiality guarantees via encryption. And these are long-term pre-shared keys. Based on these observations, we codified the expectations of the BPSec protocol, specifically that it is a non-interactive application layer secure channel protocol, providing you with either integrity or confidentiality. And this analysis assumes pre-shared keys and that the identities sharing these keys are known ahead of time. Our model also captured authorized intermediate nodes processing on behalf of the destination nodes, which means that we also capture, and BPSec by definition, considers groups of nodes that share each of these keys. So the security guarantees that we prove all hinge on a certain assumption, which is that the symmetric keys are not compromised. The adversary doesn't know these keys, because the second that the adversary learns these keys, kind of all bets are off in terms of security guarantees. No confidentiality, either in a perfect forward secrecy, post-compromise security notions, and no integrity guarantees. So we have these long-term symmetric keys that are potentially not updated for long periods of time, which provide us with these security guarantees. Which means that we need to consider and how to handle usage limits for encryption. It also means that we need to worry about what happens when keys are compromised. So we're going to talk a little bit about key wrapping and kind of talk about the limitations of key wrapping. So key wrapping merely prolongs, it does not solve the problem of key usage limits. And in addition, because all of these keys are being pre-shared long-term symmetric keys that are being used throughout the lifetime of the communication, any kind of compromise of these secrets, even in the key wrapping algorithm, completely destroys security guarantees. So all of this is to say that we have to consider what happens when keys are compromised, either due to bad usage or bad handling. The real question is, how can we refresh these keys in a secure way? So typically this is done by key exchange protocols. So key exchange protocols are handshakes that enable 2 or more parties to generate fresh, independent shared session keys. Probably the most famous example of this is the TLS protocol, which you can see on the left-hand side here. Again, not going to go into super amounts of detail. So TLS provides us with forward secrecy. It generates keys between these two parties in a way that the compromise of the long-term secrets don't impact previous communication security. And it also provides key update mechanisms. Alice and Bob can ratchet forward their secrets, allowing them to establish a handshake once and then continually ratchet forward their keys. However, TLS isn't a good choice for the asynchronous setting and thus the interplanetary setting. This is because TLS's handshake fundamentally requires synchronous communication. We can see here on the left that Alice will communicate to Bob, then Bob will reply back to Alice, and then Alice will finally send the final flight of messages back to Bob. And so this is a 1.5 round-trip handshake in order to establish keys that can actually be used to encrypt things, to be used in BPSec. But there are other limitations on TLS, using TLS as a key exchange protocol in this setting. It doesn't provide us with any kind of post-compromise security guarantees, which means that once the session keys are compromised, all future communication is also compromised. And there are risks for using it in low latency environments, specifically using zero RTT. So unfortunately, the TLS handshake is not a particularly good fit, but perhaps we can use the TLS handshake, establish the keys once, and then use key update to continually establish fresh keys. Unfortunately, this is also limited as a solution within this setting, specifically because TLS's key update mechanism does not refresh randomness. It doesn't provide any additional entropy. It simply ratchets keys forward. So this means that we do get forward secrecy, but we don't get post-compromise security. As I said before, zero RTT is also not a great solution for this setting, in particular because it doesn't provide any inherent replay protection. This is straight from the TLS RFC. In addition, if you're using zero RTT in order to establish secure communication, you also lose forward secrecy. And so considering this and trying to consider what solutions look like within this setting, it led us to the question of, is key exchange even the right protocol to be considering here? Support for asynchronous communication, recovery from packet loss, being able to achieve perfect forward secrecy and post-compromise security implies a demand signal for continuous key agreement, not key exchange protocols. So key exchange protocols are kind of distinct from continuous key agreement protocols because key exchange protocols are typically session-based. You're meant to establish a handshake and then use those keys for some limited period of time, not for a significant long-term, long-lived session. And so our question became, why not use an existing standardized CKA within this setting and use it to establish keys for BPSec? And then that way, this only adds key establishment messages, and the rest of BPSec can be used as is. And so the solution that we considered was RFC 9420, messaging layer security. So messaging layer security, or MLS, is a secure continuous key agreement protocol. So it fits the type of protocol that we are considering here. It's asynchronous, which means that Alice can update her state, can generate some fresh entropy that can be kind of put inside the CGKA state, and then send that to Bob without Bob needing to reply. Key updates can be unidirectional. Sessions are long-lived, which means that the threat models, considering the security of these types of protocols, matches the setting that we're considering here. And MLS can also optionally handle groups of devices. In terms of security, MLS gives you end-to-end authenticity and confidentiality of the keys against an adversary that is in full control of the network and can also compromise some state secrets, thus providing us with forward and post-compromise security. So on a high level, I'm not going to go into this at too much depth. On a high level, Alice and Bob can continually inject fresh entropy into their state, thus allowing them to derive new secrets per epoch that allows them to achieve forward secrecy and post-compromise security. This is a very simple depiction of MLS. Okay, so our proposal then is the addition of key agreement messages to BPSec, thus achieving PCS and asynchronous updates. So we're kind of just replacing the establishment of these pre-shared keys with MLS handshake messages. We did some proof of concept benchmarking to show the practicality of this approach. and show that it on a high level achieves on the same order of magnitude as TLS handshakes. And we give on the right kind of the expected protocol flow between Alice and Bob. They establish a MLS group, and then whenever Alice wants to update their state, they're able to generate new key packages that update their shared secret and can push that to Bob, requiring no input from Bob's perspective in order to establish fresh keys. Okay, so yep, that's 10 minutes, so I'm out of time. So the core idea, add MLS key agreement within BPSec, otherwise BPSec remains the same. And so we were hoping to gauge the interest of the working group in this approach.
I'm going to jump in because I'm in the queue. Thank you, Benjamin and team. I think this is fascinating. I think this is really interesting. My follow-on question is, for the MLS packages and communication, would your next step be to define a standard encoding of these messages to be carried within a bundle protocol and reserve a service point for the key exchange service that would implement MLS or the MLS protocol and how that would interact with BPSec? Because if it is, I'd really like to see that personally. I think it's really interesting.
Yeah, I think that makes sense as like immediate next steps in terms of trying to establish a solution for key establishment within this environment. Yes.
Fantastic. In which case, yeah, please keep up the good work. I would suggest to the working group to read this. I know crypto is hard, and it's sometimes hard to read as well as hard to understand. But this is, I know that this whole team is doing some really good analysis on BPSec and how to really make it deployable. So I have enjoyed reading this, and I think others should read it for their own good and well-being. So thanks, guys. So
thank you very much.
Hopefully we now have Teresa's slides.
All right, I do have Teresa's slides. Teresa, I'm going to share my screen. And
okay, hopefully it works now.
We're getting there.
We're getting there. We're getting there. Okay, there we go.
With something.
All right, please go ahead.
Okay, so what is a presentation without some technical issues? Okay, I will also go a little bit fast through my slides. I did this presentation already 1 year ago. Some things have changed. So as we know, we will have some congestion problems when we have different types of interconnected devices and traffics and many networks when using bundled protocol and DTN. The biggest case or the most close in the future case is the Earth to Moon communication link. So there's a need for QoS management in bundled protocol. And for that, I am proposing a quality of service extension block to bundled protocol. Next slide. The main proposal here is to have a user quality of service extension block, also called UQEB. This block would have the information that the user sending the bundle says about the quality of service requirements, and need must not be changed when traversing the network, so it must be mutable, and that's why in this graph it's shown that it has to be authenticated along the primary bundle block with the bundle integrity block. You can also see in this picture something called the network quality of service extension block. This is an option that the networks may choose to have in order to translate some of the requirements according to internal policies or for resource constraint nodes. However, I will not go into it since it's not going to be standardized because it's going to be very network or administrative domain dependent. So for the user quality of service extension block, it has the basic structure that any other extension block has with the canonical block extension information. And the interesting part is that we will use CBOR maps in order to put the information about the quality of service requirements. This allows us to have always the type of quality of service requirement along with the value that it requires, and it eliminates the possibility of having lost values or single values that don't really match to anything. Next slide. Okay, next. So there are 4 values or 4 quality of service parameters that are currently envisioned to be added. These are traffic prioritization, required reliability, latest only delivery and bundle storage. I'm going to go into depth for all of them. Values 4 to 23 are reserved for future use. And as you might see, I only use values 0 to 23, so 24 values. This is because when using 24 values only, we can use what it's called a 1-byte CWOR tiny field encoding for compact representation, meaning that in using 24 instead of, for example, 25, we can really shrink down the size of this extension block, making it more efficient and reducing the overhead. So if we can go to the next, I think you can actually go directly to the next. The first value the quality of service parameter that I want to talk about is traffic prioritization, meaning how fast does a bundle need to be forwarded when being in the queue. The names have changed since the last time I presented this. So now we have expedited, normal, which is the former high priority, and bulk, which is the former low priority. Expedited is assigned 0, and these are the bundles that are, let's say, life-threatening, for example, or things that need to be transmitted as soon as possible without any further delay. Then normal is the kind of information that has to be transmitted in a timely manner, but it's not absolutely critical. And bulk is, as the name says, any bulk science data, things that don't need to be transmitted in a timely manner. If we go to the next slide, we can see that expedited only has 1 value. However, normal and bulk have 12 and 11 values respectively. This allows for a granular approach to prioritization. So expedited, normal, and bulk have a strict priority scheme, strict prioritization scheme, meaning that normal will only be serviced if there are no expedited bundles waiting, and bulk will only be serviced if there are no expedited or normal bundles waiting. This means that if we have a very long normal queue, bulk will not be serviced at all. However, within the 12 and 11 sub-priorities within normal and bulk, there should be a first scheduling algorithm to avoid the starvation. There is an algorithm that will be included in the CCSDS Orange Book that I am currently writing, but I will not get into the specifics now due to time constraints. So we can go to the next slide. The next quality of service parameter is required reliability. This has also changed a little bit. So there are values reserved for reliable communication and for unreliable communication. And this, as of now, only represents the selection or configuration of the convergence layers adapter with respect to ARQ capabilities. So right now, 0 means that ARQ needs to be enabled. 1 means that ARQ needs to be enabled if possible. And then 22, ARQ should not be enabled if possible. And 23 means that no ARQ or ARQ must not be enabled. Values 2 to 21 are reserved for future use, and it's done in that way so that there is some symmetry to what reliable and unreliable is. If we go to the next slide, we can see the values for latest only delivery, which is currently a binary flag. Latest only delivery means that if we have a sequence of bundles, all with the same source and destination, and this binary flag is enabled, it means that only the latest bundle is valid and all the others must be deleted. This is useful if we have, for example, as sensor networks sending values every X amount of time, and then they all meeting the buffer. So 0 means that they're all valid, 1 means that only the latest one is valid, and there's values reserved for future use for further granularity. And the last value, the last quality of service parameter was also not presented in the last presentation. It's, yes, you can change slide, sorry. It's the bundle storage, which indicates which bundles should be dropped first should the queue in the persistent storage be full. So there's simply classes 0 to 23, so 24 values. And if no bundle storage class is assigned, the default will be class 11, so in the middle, and then the bundle should indicate higher or lower class depending on if it's not important that it's dropped, or if it should absolutely not be dropped in case of full storage.
And Teresa, I'm going to ask if we can pause here only because we are at time, and we will start losing the room as we go. But what I will say is we do have the slides available. They will be uploaded and available through the data tracker. We should be able to take any additional questions related to that. And we are asking for the working group to review and comment on what is being presented here.
So,
yes, the rest of the slides are conclusions, so it's perfect.
thank you very much, Teresa. I'm gonna add one more point. I think the first of those 4 features you're putting in the CCS document, I would really like to see just the flow marking written up as an IETF document, and I am willing to do the typing because I think it's that important. I will make space to do the typing. So if I will reach out to you promptly when I get home and the jet lag passes with a GitHub URL with some markdown where we can just start typing some text. If you can check that your work program allows you to do that contribution, remember you're under IPR disclosure here anyway at the IETF, but it would be great to get just that small piece out because it's really critical and I really appreciate the work. Otherwise, thank you very much everyone for attending. I think that's the end of the session because we're out of time.
We're out of time. Thank you so much. See you in Madrid.
Boom. Thank you, Adam, for taking notes.
Oh, we're done. That was a jam-packed. There's a lot of work.
You're more than welcome. Can I go to sleep now?
There is so much happening, and I got to pee. Good to see you. Hey, you. I have to go to the bathroom. I have to go to the bathroom.